accepted.
So, hello everyone. My name is Chris. I work at the Advanced Technology Center at Accenture in Poland. And today I want to speak to you about one of our key consulting and research products that we release annually, which is the Technology Vision Report. It's a very specific, very interesting publication because when you look at it, it's something that we at Accenture have been publishing for over 20 years. And every year, our researchers, also our consultants, they interview our business partners, they interview also the tech experts, they conduct a full research, and they try to create a forecast of the technology trends that will be dominating in the upcoming decade. And it's very interesting when you go on the report side and you see the full report, there's a comparison and a path how different trends evolve into the next ones in the following publications. But I'm not going to go specifically through the report. I'm going to focus more on the content, what is actually in there, because that's the most interesting part for you as developers. So, as every year, the report, the vision shows 4 trends that, in our opinion, will be dominating, will have the most significant impact. And there's going to be a lot of buzzwords today, because those trends, when they are not created solely on the look into the future, they are based on what is happening today. So the research is analyzing what is actually happening on the market right now. So that's why it won't be surprising to you that the keyword for the Tech Vision this year is the metaverse. Because at least for the last year, in the mainstream conversations, metaverse has been the loudest buzzword out there. Facebook even changed their name to Meta to be more associated with the metaverse. Microsoft has been also preparing products to support this vision. But as you will see, in the first trend, which is called WebMe, the metaverse is actually already here, and it's absolutely different than what we've imagined so far. But metaverse is just one element of the tech vision. The tech vision actually is talking about a continuum, because the metaverse and the technological development in the upcoming years will be shaped not only by the virtual world, but it's a combination of different technologies. So that's why we're talking also about programmable world, we're talking about synthetic reality, and we're going to talk about supercomputers. So when we talk about meeting in the metaverse, we're talking about going into this large continuum. And the continuum is comprised of different technologies. Not only the VR, but it's also extended reality, augmented reality. It's also blockchain. It's also artificial intelligence. It's digital twins. It's IoT, smart objects. It's edge computing, and also supercomputing. And the technological aspect is just one part of it, because there's also the spectrum of the new emerging experiences for users. And that's actually the biggest change when we talk about the metaverse, because we're talking about so-called change of the user interface. We're not going to use a keyboard and a screen. We're going to use probably all our senses to interact with people, to interact with applications. It's also going to change completely the business models and business applications aligned with it. And why am I speaking about this on Devoxx? Because most likely you as developers will be the guys and girls to create that, to bring those promises to life. What's also interesting is that we're talking about mixing virtual and physical realities. And this is a trend that is also, it's not visible on first sight, but when we look deeper into it, it's really surprising how it's developing. And finally, one last thing about the tech vision is that it talks about very early stage projects. So this is a forecast for the future. So the researchers, they are talking about things that are happening now, but when you look at the metaverse in its current shape, this is very early stage. It's not ready to be rolled out full scale. And why we're talking about early stage projects? Because the tech vision is also aimed to give some guidelines on which areas we should focus in the future, on which areas we should pay more attention to, some benchmarks, to observe them, how they are going to develop. Because from these early stage projects that I will mention also today, somewhere, sometime, the final solutions and the final standards are going to come out. So I'm going to try and squeeze into the time I have. So starting with the metaverse and the WebMe trend, this is actually a discussion about the new internet that is going to emerge. And when we talk about the new internet, we are talking about two main concepts that are going to be the foundation of it. First, we're going to talk about Web3 concept, which is currently mostly associated with cryptocurrency. And probably there are some people here that know way more about it than me. But the interesting part is that Web3 is not only related to cryptocurrency, it's also related to building a distributed internet and to building a new way of storing and sharing private data on the internet. So one of the key challenges the Web3 people want to solve is how to transfer the ownership of our personal data back to the person that owns it, should own it. Because right now, when we go on the current internet, we have multiple platforms. Everywhere we share some data. And then whenever we do that, we actually, in many cases, lose control over that. So most of us don't know who has access to our cell phone number, to our mail, email, to our name, sometimes even the data that is obtained from tracking cookies or other applications. Because except for the big players that have to be compliant, there's a lot of applications going around on the internet that are also collecting that data. Smaller companies, they go bankrupt, they sell their databases, new people obtain it. There's absolutely no control over who gets access to our data. So one of the projects that you'll see, led by Sir Berners-Lee, one of the founders of the internet as we know it, is focused on creating a new way to store that data and to build the so-called data stores that will allow us bigger control over who, when has access to the data store with our private data. But the privacy is just one aspect of the Web3, because then we have NFT. And when we talk about NFT, we are not talking about selling JPEGs for large sums of money. We're talking rather about a blockchain-based solution for ownership on the internet. And at Accenture, we cooperate with a lot of big brands from different sectors, goods sectors, retail. And all those brands, they are looking at the metaverse as a new market to sell. And you'll see there are some hilarious examples already where luxurious brands are selling their products virtually, and even virtual products. And it all requires some way to preserve the ownership, to underline the ownership. And that's where NFT tokens, they come in. But Web3 is just one part of it. Then we have the metaverse itself. And it's, as I mentioned, it's far more than just the virtual reality aspect. We're talking about, for example, building the digital twins, which are digital models representing pieces of our real world. Then we are talking about these already mentioned virtual products and objects, which can be obtained and sold and traded based on NFT. Then we're talking about also different extended reality solutions. And I'm going to jump into that in a moment. So a few examples of how Web3 can be utilized and how it's happening already today. So I've already mentioned the Solid project. But this is an interesting part, because NBA created a product called Top Shot, where they are selling actually virtual trading cards which, because they are digital, they are not just pictures, they are short videos of moments from the NBA games. And because they are NFT related, they can be traded. So as maybe you've heard in America, these sports collecting cards, they have been a big business for many decades now. And now they are trying to use NFT to make it a little bit more tech advanced. So you can collect these, and you can buy these Top Shot packs, where you have no idea what is in it. You have to unwrap it like any card. And then you see some action from one of the NBA games from the last season or from another season. And then if you have 2 or more of them, you can trade them with other people, and you can build your collection of these. So this is just one example. But the most hilarious one is this one, where Gucci was able to sell a virtual bag, which was a virtual copy of their real bag, on on the Roblox platform for over $4,000. That's more than the actual product costs in the real world. And people want to buy this. There are stories, for example, of skins for Counter-Strike Go, where they were paying also thousands of dollars for a unique skin for their gun, for their uniform. So this is a quite big market. And as we all know, the problem of authenticity on the internet today is a big problem, because it's data, you can copy it. So how can we prove that you have the original? How can you prove that you have the one thing that is authentic? So this is why we come back to NFTs, which will, theoretically, they are a way to prove that you have that #1 version, that original, not the copy. So this is the one part. Now, when we go to the metaverse, when I started preparing lectures about tech vision, I had absolutely no idea that Roblox exists. Probably for some of you, it may be the first time as well. But Roblox, which is not a very advanced graphically platform, is kind of the metaverse today. People go there, just hang out. They don't do anything specific. The games, they are basically quite simple when you compare them to, I don't know, multiplayer online games. But people are flowing to Roblox, and companies are building special areas in Roblox to promote their brands, to get in touch with their customers. And Nikeland is one of those examples, where they've created this whole zone which allows to integrate with different applications. People can submit, for example, their from their Strava or other applications, the results of their training. They can obtain some discounts. They can get access to unique products. So, and this is showing us the direction where the big business wants to go with the metaverse. But right now, the biggest challenge is that all of this is separated. So we have all these platforms separate. So whenever you want to enter a new platform, you have to build it from the beginning. There's no way how to interconnect. That's one of the challenges that is coming there. This is also very strange for me personally, because this is another virtual world where you can buy virtual property based on NFT. So you can buy virtual land, which is related to NFT, and it also costs, it's getting more and more expensive. Also, the big brands, they want to be on this platform. This is another one. But I've mentioned to you digital twins, and this is, I'm an old guy, so for me, this is the more exciting part. BMW, together with NVIDIA, based on their Omniverse system, they've created a fully digital copy of one of their manufacturing plants. It's a 3D model, which is an exact copy of the plant. And it's a great tool for simulations, trainings of their staff, checking how, for example, moving machines and changing the layout of the plant will impact the productivity and the effectiveness of processes. But it's also related to data coming from different sensors around the plant. So when we are talking about a virtual model, it's not just to make a 3D walk around the plant. When you click different machines, you get access to data from the reports, from the dashboards that are connected to the IoT sensors everywhere. And what is important about the concept of digital twins, which has been already flowing around for a few years, is that we're gathering the data, we're trying to recreate a model of where the data is coming from, and then what it allows us to do is then, based on machine learning algorithms, we're able to run simulations on this virtual plant instead of going to the physical one. So as you can imagine, for example, when planning different plants, manufacturing plants, or when we move, for example, to the concept of retail stores, you can create a virtual retail store, experiment with the layouts, with different other concepts, almost cost-free, because you don't have to do it physically. You can have a pretty much realistic virtual model that gives you very accurate results. And this is another aspect of the metaverse, where we are creating copies and twins of our real world. So just to summarize how we think the new internet is going to change, I've mentioned it's going to be around resolving these problems, so the personal data ownership, resolving the problem of multiple platforms, so that when you are virtual, you don't log out from one application, log out to the other one. You have to have some sort of interface between them. And then also new forms of interactions and contact. And this is just the first trend of the tech vision. I'm trying to squeeze as much as I can. But if you are interested, make sure to visit behind the QR code the full report, which is 100 pages long with the source material, links to different pages, weblogs, etc. It will give you way more insight than what I can squeeze into an hour. It's going to be on every slide, so don't worry. So this is just the first one. The second trend that the tech vision talks about is the programmable world. It's actually the discussion about how the digital revolution is entering the physical world around us. So it's all about IoT, it's about extended reality, it's about 5G connectivity, the digital twins, but also something that was interesting for me, extending the connectivity infrastructure, for example, for different assistant platforms. So, for example, there are some neighborhoods being built where you can walk out of your home and still be in the range of your Alexa or other house assistant. Because that infrastructure is extending the range of your assistants and other connected devices so that you can use them around the neighborhood for different services as well. So, but when we talk about the programmable world, we're talking about 3 layers. The first one, which is well known to us, is the layer of the connected devices, the connected layer. So it's the IoT devices, it's the smart devices, it's the sensors, fridges, but it's also the connectivity. So you have to have at least 4G or 5G connectivity to make them work. And once we have that, we can start talking about the experiential layer, which is built upon all that data that you can gather from all those devices that are out there. And this is firstly related to being able to access all that data quickly. So we're talking about providing 5G connectivity at least to avoid delays and to have the right bandwidth. And then we're talking about creating these digital models to provide us with real-time insights. So when we talk about the digital twins, it's not about something you recreate post-factum. It's something that you can access real-time. So it's like when we talk about manufacturing, this is like the dashboard of the future because you access the real model of the plant and you can see what is actually there with micro delays, if at all. And then we are talking about augmented reality, which is which will be becoming even more important every day, because the tech is already there from different producers. And now it's the augmented. When we talk about augmented reality, it's making all that data that we gather, that we have somewhere in the backend, available to the workers in the plants. So using HoloLens or other products similar, you can get access to reports running from a machine just by approaching it, and you can see it on your lens. It's about completely changing the way maintenance is done, because you don't have to have all that information just in your head. You can also, using augmented reality glasses, approach a machine and get access immediately to schematics, to performance metrics, to historical data, current data, predictive data, etc. And the last part, which was a bit surprising for me, is the material layer, where we stop talking about data. We're talking about actually creating smart materials. And we're talking about building and manufacturing materials. So for a great example here is how we have new knitting techniques. So for example, when you want to create a garment, a t-shirt, trousers, a dress, you don't have to cut it, sew it, you can print it. And there's, for example, a product called Knittable, where you can buy a 3D printer for cotton or other materials and print out your dress however you want it. And this is, for example, for the textile market, this is a revolution, because you can, for example, start moving the production out of the big factories somewhere in Southeast Asia, and have, for example, small printing houses, textile printing houses, where you can have full customability, and you can have full customization, and you can have it accessible immediately after ordering through, for example, an e-commerce platform. But 3D printing is not only reserved to these smaller projects or to textiles. We're seeing, for example, companies which are introducing 3D printing into construction, where we have 3D printed houses. And this is also something that is going to keep on evolving. And also in the food industry and in others. You have companies which are 3D printing spare parts for different machines or devices. And when we talk about this, the key aspects are the customization and democratization of design. So this will be interesting for you, because it means that when you create an e-commerce platform, you have to give some way to the users to start designing their products. And this is already here. The big, for example, the big shoe brands, fashion brands, they already give a lot of space to users to customize, for example, their Nike shoes. And then we have the programmable materials. So there are two right now, which are called voxels and xenobots. These are very early stage research materials. Voxels are specific, it's called a meta material. It's kind of a small cell that can adapt itself to different shapes, and therefore it can connect also more easily to others. And it's something that is being worked on as a construction material. And then we have xenobots, which are actually small programmable organisms which are being created from stem cells. They are not like they are organic, but synthetic at the same time. So when we talk about the digital revolution in the physical world, it's all fun, but then a big challenge is the expanding field for attacks. And this is something that will be a big challenge when this is becoming more popular. Because, for example, when you walk out in a neighborhood which is all linked to different smart devices, giving you all access to those assistants, to different apps that you own. It also creates a large field where you can be attacked and your data can be captured, can be intercepted, where you can be pulled into a false app or some copy or some other kind of falsified system. And solving this would be one of the challenges here. To provide, when we create this great connected world, to make it secure. Then another challenge is we have a lot of emerging ecosystems and different suppliers, and how we can make these things connected. How we can make it more easier to connect all those devices to each other. And from a regulatory perspective or business perspective, there's still lack of standards and certifications that will unify this somehow and give everyone a same standard to follow. But moving on, the third part of the vision, of the tech vision, is even more exciting because it's related to creating a synthetic reality. So I've been ignoring a lot of these parts before I started digging into the tech vision. But actually, the part where AI is creating content, it's actually there for a few years. This is not something new from the last year or the last 2 years. This has been experimented for a few years now. The problem, the challenge is that it's no longer in the experimental part. This is starting to become something that will be a service that people will want. And when you link it to, for example, the capabilities of 3D modeling and what we can achieve with deepfake, we start talking about creating, for example, fully synthetic AI characters that can be used, for example, as in China, for a news anchor. So the news anchor in Xinhua, it gets all the information by text, it prioritizes it, and then through text-to-speech conversion, the 3D model of the anchor is giving the news to the people. And it's created every time real time. So when you access it, the bot speaks to you. And it's like watching the news, except there's no recording, there's no studio, it's all generated real time. And this is going to be very interesting when you think about the capabilities of this, because you can have, for example, for all the administration work, virtual consultants in banks, in public administration, even health assistants. This is something that will be rising, definitely, because it allows to save a lot of money, and it gives you a full scalability that is not possible when you use physical people. But we are also going to talk about this is about creating bots that can share the data. But when you think about it, if the bots can share data, why can't they write news? Why cannot they write blogs, articles, etc.? And this is the next part, yeah, where the AI is going to be creating content, because again, it will be cheaper than hiring people, and it will give you more control and more standards. And when you link it, for example, to data that we can get from the analysis of people's behavior, what we had with Cambridge Analytica, for example, then you can create multiple streams of content easily, because the bots will be able to follow rules to create content to meet the expectations of different client sectors. But this is the part related to bots. Then we have also very interesting part where, based on modeling, we're able to create fully synthetic data sets. And this has been used already for the COVID-19 treatment, because in Italy, based on the records of authentic patients, they were able to recreate synthetic records of non-existing patients, which were realistic and could be used for research projects around COVID treatment. And this is why this is important, because it allows us to avoid the problem with privacy, with people not giving consent to share their data. And when we are talking about modeling based on data, we are no longer prone to this. And so for medicine, this is one aspect. Then it allows us to accelerate medical research or different or other kinds of research which are related, for example, to gathering data from people, because we're able to expand significantly the size of the data sets. And another aspect is trying to create a positive bias for AI training, because this is a big challenge when we talk about using real data. You've probably heard about the story where one of the big companies was using an AI assistant for recruitment, and based on the analysis of historical data, this recruiting bot had a perfect bias towards women, because it learned from the historical data that women are less likely to have managerial positions, and they are usually paid less. And this was just emerging from an analysis of the data at this company from, I don't know, 5 or 6 years or even longer going into the past. It was replicating the bias that people had. So if we want to avoid AI replicating those biases, then using synthetic data, we can provide data sets which will be big enough to train it without those biases. But of course, synthetic reality is not only about fun, it's also about the increased risk of attacks, because using voice replication, even today, AI is able to replicate our voice based on some patterns. Once this becomes more broadly available, there will be a much bigger risk that, for example, you can be called, I don't know, by your grandmother, mother, and asked for money. Yeah? And you will be fully convinced that it's the real person, because based on the voice you hear, you will recognize the voice. And if we collect enough data, the bot can also have a realistic personality of what it's trying to replicate. In the report, there's a story about a guy who created a replica of his dead girlfriend. Based on the conversation histories, it created a bot. He created a bot that was giving a really unauthentic feeling of talking to the real person. And this is Black Mirror season 2, except for the clone. But we're already there. We can create a replica of real people. So this is a big challenge. When we think about the problems we already have with fake news, with the internet as we have it today, it's going to be a big challenge, because it will be very simple to create a replica of political leaders, church leaders, different people, and show them in different contexts that is not real. But the people will have no possibility of identifying that it's not authentic. And that's when we talk about, that's why we talk about authenticity being the biggest challenge right now. There are different experiments like Project Origin, or for example, the work of the Streambet startup, where companies are trying to create some mechanisms, some ways where authenticity can be proved. NFT is again being looked at, or blockchain is being looked at as one of the ways how this can be proved. So, because we need to stamp content somehow and be able to show that it's real. So it's like the certificate mechanism that we have on the IT systems, but we have to make it for other kinds of systems. So we don't know how to do this. Project Origin, led by Microsoft with BBC and New York Times, they are still in the experimental phase. There's no real solution for this problem yet. But except for the authenticity part, there's also a question of regulating the content that is created by AI. Because there are absolutely no regulations. No one has been talking about what can be created using AI or 3D and deepfakes so far. And if we can create perfectly realistic models, then I have in my head at least 5 illegal types of content where this can be used and probably will be used and will become very popular. So the regulations, they need to be there because unless the law regulates it, it will get out of control pretty fast. And also the regulations, they need to be there to link it. For example, if we have a standard for proving authenticity, then it needs to be supported by law to use it. Otherwise, if we don't have the standards in law, they will not become broadly used. And last but not least, the last trend related to supercomputers, where we have the biggest buzzword of all. We have quantum. But actually, quantum is not so important in the tech vision because generally we have a very tiny piece of the computing power of the qubits that are required to make the full use of quantum so far. The quantum computers are already there. You can use them. You can access them through quantum virtual machines. But this is more about learning how to program them, searching for algorithms that can be used, because we all know that this will be a complete revolution in programming. So not much change here. But this is a very important, interesting part. Building high-performance computers and using massive parallel computing. Because this is something that is already there, and it has been used again, for example, with the COVID-19. So there's a project for analyzing cells called Folding at Home, and this is a network of connected machines where you can share the digital power of your processor for computing operations. And during the COVID-19, they were able to link 400,000 machines, which allowed to map the structure of the COVID-19 virus. And it also broke something called the access scale, which is the scale of I'm not good with mathematics. It's access scale is the number of operations behind the pointer. A very large one, and usually it requires a very big computer. But when we here using house computers, they were able to achieve the computing power with minimal effort, just based on applications actually that allow to link those machines, that allow to build a computing network distributed around the world, and divide the operations there. So this is important because this is supercomputing within reach. And when we look at the next example, which is Tesla, which actually built its supercomputer physically, the first part will be probably something that the demand will be increasing because we're starting to reach the moment where we need to process large amounts of data. We need to solve very complex computing problems. And big companies like Tesla, like Google, like others, they will want to increase that computing power. And by creating these networks of the connected machines, we're able to give them that. And also, when we if we think about the amount of machines that are in a standard business company. Let's say Accenture, 500,000 employees around the world. Imagine that you could start using that computing power when people are not working. So I finish my work, but the computer stays on, and its power is being used as a part of this computing network for parallel processing. So this is something that most likely will become more important, because especially when we talk about blockchain, when we talk about AI, there is an increasing need for computing power. Tesla built its Dojo computer just for the purpose of computer vision training for the autonomous cars. But then let's think about, for example, other autonomous machines for industry, for other sectors. So the demand will be there. So again, there will be a challenge to deliver systems that are able to utilize this. But then the last trend is also last part of the trend is very, very interesting, which are the technologies which are mimicking nature in design or in architecture. So one of the latest parts is the DNA-based storage models. Microsoft has announced that they are able to deliver this. So when we talk about DNA structure-based storage, it's using the model of the DNA to create a different way to organize and store data, which is more accessible, faster speeds, and bigger size of storage, significantly bigger size of storage. So this will be when we think about now that we have hundreds of millions of sensors, devices which are gathering data. That data has to be pushed somewhere. It has to be stored somewhere. It has to be also accessed quickly. Because with 5G connectivity, when we get over the bottleneck with transmitting the data, we will reach the storage bottleneck probably. Or we will reach the computing power bottleneck at a certain moment. So the DNA storage allows to, at least for some time, overcome the bottleneck with storage capacity. But then we have, for example, the neuromorphic computing idea, where the AI models are more built based on the neural network, the synapses of the human brain. I know it should have been like this so far, but as we know from the university, the virtual synapse is not as we imagine it to be. So right now they are more closely trying to mimic the way the human brain works. And when you look into the neuromorphic computing, the biggest advantage that it gives to people is that it allows to lower the amount of power which is required for AI training. This is the main purpose of the neuromorphic neural networks, because with lower power demand, lower demand for power for computing during training, it will allow to move the training of AI to edge devices, and that's the main part. Because when we are talking about intelligent robots that can learn, right now with the current structure of the neural networks, it would require a truck with a battery to power it for a longer time. So the concept behind this is to have a model which allows to provide AI training in edge devices. But there are also, when you look at it, look through the internet, you will find that the nature mimicking trend is going not only through IT. It's also going around through construction, through architecture, because we're able to find structures in nature that allow us to resolve complex problems more efficiently than what we've so far created. So the Tech Vision, it's not a scientific report. It's a report that is meant to inspire you and give you certain ideas what to look at. So that's why I'm not talking about specific code ideas, because those solutions, they are emerging. They are different. In most of these areas, there are different solutions competing with each other. The main purpose is to give you the awareness that it's there, the problems are there, the trends are there, it's developing. If you want to, you can start following some of those trends, start searching for the sources to follow what is important for you. But on the other hand, you may have a strategy where, okay, those trends are there, but this is too early for me, so I'm not going to, it's not worth my attention yet. But you are aware that certain things are already happening. That and this is also because the audience of this report is not only developers, not only tech people, but also business leaders, managers, who are running those big companies. And the question for them is, should I invest in the metaverse right now, in its current stage, or not? And for some companies, the effort will be worth it. For others, it will not. And the idea is to not be caught by surprise. If you decide to go and follow those trends, it's important to remember that you don't have to go alone. And as you will see in the report, many of these projects, they are run in partnerships, sometimes between competitors who decide that it's better to share the costs because anyway, in the future, they will both use this technology. It's also about investing in the right competencies. So even if you are a Java or .NET developer, maybe it's worth getting some skills related to what will be needed for the metaverse. So, for example, when we are experimenting with these different virtual worlds, what you've already seen is that there is going to be a very big demand for integrations, for interfacing. So how can I interface an application from which I have on my mobile phone with a virtual world? For example, there's also the challenge of user interfaces in general. There are funny videos where some retail brands from the US, they are showing a virtual shopping experience where you are pushing the shop cart to the market and taking virtual bottles or products from the shelf, which is not exactly what you would like to do in the virtual world. The companies, the business will approach the market for people who can design quality interfaces. And when we talk about virtual reality, it will most likely be very likely to the interfaces built for augmented reality or for gaming or others. And the same goes for all the other trends. So I really encourage you to follow the report, see what's there, because it's also one of the ways how we can deal with what is coming is seeding these ideas in your teams, in your companies, and investing in innovation, in early experiments with all of these. You might not be building the final solutions yet, but just to have some awareness of the technologies. And that's it. I managed to do it with 1 minute spare. So thanks a lot. And sorry if I was not able to explain exascale correctly, but it's not my specialty, unfortunately. Yeah, thanks.